Hello, this is Imtiaz Ahmed. My ID is 17301140. This is our CSE461 final project, the line following robot, and I'm here to talk about the robot building part. So let's get started. If we go inside robot, then children, here we can see all the components that were used to build this robot. Firstly, for the body shape, we have used geometry box. Then for the four wheels, we have used four hinge joints. If you go inside hinge joint device, we can see there is a rotational motor for each wheel. These rotational motors will help the wheels to rotate, and so the robot will go forward. For the naming, we have named the rotational motors as wheel 1, wheel 2, wheel 3, and wheel 4. We have to remember these names and use them in the code. For here you can see wheel 1, wheel 2, wheel 3, and wheel 4. These names need to be same, otherwise the robot will not function properly. After that, we have used three distance sensors, and named them as right, left, and middle. In the code, we have to use these names too. And if we click on the distance sensors, we can see the coordinates, how it's working. And let's have a closer look. We can see the X-ray is pointing downwards. Why is it pointing downwards? Because it has to perceive the line underneath it so that it can follow the line. So yeah, that's all from me. Thank you.
Hello, I'm Zarina Nanosha, and now I'm gonna make the black line for our robot. And for this, we're gonna go to Tinkercad. In Tinkercad, we're gonna create a new design, and we'll use Scrabble. We'll make as many curves as we want, and after this, we'll make the height as low as possible. I'm gonna make it close to 0 and make the color black. After this, I'll export it and download the OBJ file. We'll go to the webboards, and in the file we'll import 3D model. We have imported it properly, and now we have to play with it a little bit to see where it is and fix it in the floor. And here is our Scrabble.
Assalamu alaikum, this is Munami Sharmita Azad and I'm going to explain the coding and simulation of our LFR robot. Let us begin with the coding part of our LFR robot. Here we can see that we have done our code in Python, and first of all here we have initialized 4 wheels and named those wheels as wheel 1, 2, 3 and 4, just like we have named those in our rotational motors. After this, we have initialized our 3 distance sensors and renamed them as right, middle, and left, like here in our distance sensors. This part of the code is going to print the reading of our 3 sensors in the consoles. From this console value, we can check and do our calibration. After this, we have to put the values here, like we have to see which values are coming over here to check, and we can see that the values are coming here 600 for middle and right, and for left it's coming as 300 range. So we are gonna calibrate and give it 600 here in the conditions so that our robot works well. Now I will do the simulation of our LFR robot. So here, when the robot sees the lines in the left, it will give a higher reading in the left and the middle sensor, so that the right sensor will go forward in more speed and it will take turn in the left. For the opposite situation, when the robot notices a line going in the right, it will give a higher reading for the right and the middle sensor, so that the left face will go faster and it will take a right turn. That's how, according to the console's value and based on our conditions in the code, the robot will move forward facing the black line. Thank you.
Previously, we simulated our robot without the PID implementation part, and now we have implemented the PID part, so we'll simulate it again. Here we have initialized all our variables, and we have written two new methods. One is the PID and another one is the set speed. Inside the set speed, it will set the velocity accordingly with base speed and balance to all the motors. In the PID, we have all our variables as global, and then we calculate the proportional, integral, and differential part. In the balance, we calculate the whole PID, and in our last error, we keep our current error and return the balance. If the value of the sensor is within 1000, it will work normally, and if it's not, then if it's bigger than 1000, then it will set speed accordingly. However, if it's 1000, it will calculate the PID of our error and set the speed of the motors accordingly. As we know that the distance sensors don't work over 1000, that's why the value needs to be inside 1000 for our robot to work properly. After implementing the PID, we see that our robot is working more smoothly than before. Thank you.